नमस्कार मित्रांनो. Today we are going to learn mesh analysis. What is mesh? Mesh is the smallest loop which cannot be further divided into another small loop. Okay, so for example, here we are having this circuit. You can say the outer one A, B, C, D, E, F is a loop. You can say A, B, E, F is another loop. You can say B, C, D, E, B is another loop. So there are three numbers of loops. But what is mesh then? Mesh is the smallest loop which cannot be further divided. Here you can say A, B, E, F, A is one mesh and B, C, D, E, B is second mesh. So number of meshes here are only two. So mesh can be a loop, but every loop is not a mesh. Okay, because if you observe, the outer loop is not a mesh. What is mesh analysis? Mesh analysis is the method in BEEE to solve any circuit having two or more loops. Okay, so here what are the steps that we are going to see one by one. See here, one circuit is given with some resistances R1, R2 and R3 with voltage sources. There may be current source also. Okay, here we are taking only voltage source. And the question is to find current in each branch by using mesh analysis. So what we have to do here? See, in a mesh analysis, we have to assume the mesh currents. We have to assume the mesh currents. Here are two meshes, 1 and 2. So this is my first mesh, this is my second mesh. Okay, I have to assume the direction of current in a mesh randomly. Instead of considering the branch current, we have to consider the mesh current. So here I am having first current I1 in a clockwise direction, and in mesh 2 also I am having another current I2 in clockwise direction. So in mesh analysis, one by one we have to apply the KVL to each mesh. So here in step 1, apply KVL to mesh 1. Apply KVL to mesh 1. How you will apply KVL? In previous some videos we have seen how to trace the circuit. So here also same thing we have to do. See here, negative to positive we have to take positive. In resistance, entry point is treated as a positive. So इथे current enter होतोय हा positive आहे, हा negative आहे. R3 साठी I1 is entering in this point and exiting from this point. So we have to consider only that much. Now here if you see, R3 is a common for both mesh. So here we have to take the difference of the current I1 and I2. Okay, because one is coming from top to bottom, I2 is going from bottom to top. So we have to take the difference I1 minus I2 for R3. Got it? So I am applying here. See, minus 2 plus V1 plus 2 minus I1 into R1, because I am in loop 1, I1 current is flowing here. So I1 into R1, and next is minus I1 minus I2. That is current in first mesh minus current in second mesh, because it is common. R3 equal to 0. We have to rearrange these terms such that unknowns, that is I1 and I2, will remain on one side and the constant term will go on the other side. So if I solve this, or I will take this part on another side. Okay, so what we will take? Minus I1 R1 minus I1 R3. So R1 plus R3 into I1. Unknown is I1. R1 and R3 values we are knowing. So R1 plus R3 I1, then minus R3 into I2 is equal to V1. This will become my first equation. Okay, so with two unknowns and other values are known, that is V1, R1, R3 are known values. Okay, I1 and I2 are unknowns. This is my first equation. हा इकडे गेल्यावर पॉझिटिव्ह होईल, मायनस I1 R3 सुद्धा पॉझिटिव्ह होईल, म्हणून R1 प्लस R3 इंटू I1 पॉझिटिव्ह झाला. पहिल्यांदा I2 पॉझिटिव्ह होता, दुसऱ्या साईडला गेल्यावर तो निगेटिव्ह झाला, I2 आणि R3. Got it? So now step 2. In step 2 we have to apply KVL to mesh 2. Okay, what will happen over here? Again same thing, we have to trace this circuit in a similar line. जसं इथे क्लॉकवाईज केलं तसंच इथे पण आपण करूया. सो काय मिळेल आपल्याला? प्लस टू मायनस, मायनस V2, इकडे मायनस. आता याच्यासाठी बघा आपल्याला प्लस मायनस डिसाइड करायचं आहे. हा एंट्री पॉइंट आहे, हा एक्झिट पॉइंट आहे, हा एंट्री पॉइंट आहे, हा एक्झिट पॉइंट आहे. सो मायनस V2 प्लस टू मायनस मायनस, आता इथे पुन्हा I2 मायनस I1 घ्यायला लागेल आपल्याला. ते आपण दुसऱ्या मेश मध्ये आहोत, त्यामुळे I2 मायनस I1 हा डिफरन्स R3 मध्ये आहे. सो दॅट आय एम टेकिंग हियर इनटू R3 and finally plus 2 minus 2 into I2 is equal to 0. So again we will rearrange these terms such that we will get what? R3 into I1 minus R2 plus R3 into I2 is equal to V2. This will become my second equation. In step 3, what we have to do? We have to solve equation 1 and 2. Okay, solve equation 1 and 2 simultaneously such that finally we will get answer of I1 and I2. Okay, we have to solve equation 1 and 2 simultaneously so that we will get the solution for I1 and I2. In the next video we will see numerical based on mesh analysis. Thank you.